It is now recording the voice that you're hearing and what's on the smartboard. Effectively, what I'm going to be starting today with, again doing the class backwards, is what a radian is, and those things up there are radians. And I'm going to start by showing you where a radian comes from, and that is, like everything else I've told you we will be doing, a radian is going to come from a unit circle. So if I were to draw a unit circle on a coordinate plane, give it a radius of 1, and say I would like to find the circumference of this unit circle, then I could say that the circumference, whose formula is 2 times pi times r, for this particular circle, would be 2 times pi times 1. So the circumference of this circle, or the distance all the way around, is 2 pi. That distance is also known as 360 degrees, so I'm going to replace C with 360 degrees. Is everybody with me so far? So 360 degrees and 2 pi, they are the same thing. That means that 1 pi is 180 degrees. Now if you take a peek at the clock I've got hanging at the front of the board, in standard position beginning right here, you see 2 pi. Somebody see it? That's because it's going all the way around. At 180 degrees, you see, over here, 1 pi. And that's the equivalent of 180 degrees. So radians are just basically counting in multiples of pi. How many pi? Well, when we break a circle into 12 equivalent parts, that means every half circle is broken into 6 equivalent parts, and that means I'm going to be counting by pi over 6s, which is this easy. Those have been reduced. I'm not reducing, but they're the same thing. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4, 5, 6 pi over 6, 7, 8, 9 pi over 6, 10, 11, 12 pi over 6, which is 2 pi. Did you follow it? 1, 2, 3 pi over 6, 4, 5, 6 pi over 6, 7, 8, 9 pi over 6, 10, 11, 12 pi over 6, and then you're done. They've reduced. I'm not, but it's that easy. Now, why bother? Well, the reason I bother is because of this. If I were to say to you this little angle that I've drawn is a 30-degree angle, you could say, yeah, that's great. But this 30-degree angle is the same 30-degree angle. And this 30-degree angle is the same 30-degree angle. And if I were to draw a circle that looked like this and extend this line, I want to extend way out to there, then this 30-degree angle is the same 30-degree angle. Yet somehow in that bigger circle it just looks bigger, doesn't it? What's making the arc look bigger? The radius. An angle measure, a 30-degree angle measurement, has no sense of size. It has a sense of rotation. An angle is a rotation. It's not a size. Radians are going to include size. And specifically, we are going to define 1 radian to be 180 divided by pi. I can't fit the word radian there. 1 radian is going to be 180 over pi. In short form, 180 over pi is the equivalent of about 57 degrees. I've very much rounded that value. It's nowhere near a whole number because pi is an irrational number. It's a decimal that never ends. When I divide by a decimal that never ends, I get a decimal that never ends. So when I say 57 degrees, it's to give you a rough idea. A radian is about just shy of 60 degrees. Now I've rounded even more. There are about 6 of them in a unit circle. And the reason that radians are so helpful to us is because we're going to define them to have a length value to them. Specifically, we are going to say that the number of radians, this is the symbol for radians. I told you when I introduced theta that it would now be a radian angle measure, that when I introduced it to give you the name, but eventually it would only be recognized as a radian angle. Remember me saying that? So radians times radius will tell me the arc length. And that's what a radian formula is. It's going to include the length of the radius, the size of the arc, and the angle measure. Remember, this is an actual angle. It's about 57 degrees, but it will be counted in pies. So when I see radians, I'm always going to see pi, or pi will have been kind of multiplied or divided in as a 3.14159625 value. So radians are always going to be a little bit of a bigger valued angle, which means I'm typically going to have far fewer of them. For a 120 degree angle, I've got just a little bit more than 2 radians. Do you know where I'm getting that from? So typically our radian numbers are going to be a lot smaller because they are a value that is much bigger. So what's their purpose? I have size. I've got length, and I can associate not just how big is the rotation, but also how big is the circle. That's their purpose. The next 10 minutes are going to be just working with radians, and here's what we're going to do with them. First, we're going to write the definition, and it's a form of measuring angles that includes length of radius and arc. Okay, now I've written into my formula here that theta is always the symbol for radians, r is always the symbol for radius, and I always remember this formula because the 2 r's are on the same side, just multiply them. S, for some reason, somebody a long time ago decided that S was a good symbol for the word arc, which doesn't have an S even in it, but S is consistently what you're going to see in any textbook that you look at on the Regents exam. S is the letter that represents arc, just like for some crazy reason Z represents magnitude. Somebody remembered it, yay. Z is magnitude, S is arc. I don't know why they come up with these letters, but random pieces of information. Okay, what we're going to do is first and foremost, we're going to write this 2 different ways, because when we're working with radians, there are essentially 3 things I need to be able to do with them. Change from radians to degrees, change from degrees to radians, and use the formula to solve some equations. That's it. So when I'm using the formula to solve some equations, the easiest way to do that is to have an equation for S, an equation for R, an equation for theta. So we're going to write the other 2. I've got an equation for S. What if I wanted to take that formula and isolate R? What would it look like then? Not S times theta, S over theta. That would be the same exact equation, just written slightly differently. And what if I wanted to solve for theta? That would be S over R. So all 3 of these are equivalent equations. Again, my own personal preference, I like to remember the original one, because radians times radius, the 2 R words go together, get multiplied, easy peasy. But they're all the same thing, and if you know all of them, that's great. If you only know this one, you should be good to go. Okay, again, 1 radian is 180 over pi. I typically write it as 180 over pi because it gives me a degree measure, because that's the equivalent of 180 divided by 3.14, or about, and again, this is a very rough estimate, 57 degrees. Just to give you a picture size, to give you some substantive measure to look at. I could, however, though, have said, since pi and 180 were the same thing, I could also have said that 1 radian was pi over 180. It just doesn't make sense in terms of degrees to say it that way. But I'm going to remind you of that in just a couple minutes when I'm transferring back and forth. Pi and 180 are the same thing. They are interchangeable. Still good? Okay, so moving right along. This is the 3 formulas that I have here. I'm just going to repeat them. And R equals S over theta. And so the first thing we have to do is work with the formula to solve for some missing pieces of information. In this one, they're asking me to find S. When they're asking me to find S, the easiest formula to use is the one where S is isolated. So I will find S by essentially plugging in theta and R and multiplying the two. They've told me theta, it's 1.5. They've told me the radius, it's 4. And that means the arc of this particular circle would have been a 6. Now just for frame of reference, so you can see what the heck I just did, they were talking about a circle where they had marked off about 1.5 radians. In our brains, for translation purposes, that's about 90 degrees. And so I'm looking at an angle that's about this big and a radius of 4, and I'm trying to find this length. Now, just for kicks, let's use 90 degrees and see how close we get. Keep in mind that's a very rough guesstimate. I'm going to do circumference and then divide it into fourths, because 90 degrees is a fourth of 360. Got it? So the circumference of this circle would be 8 pi. Agreed? Divided into fourths would be 2 pi. And 2 pi is 2 times 3.14, roughly 6. Okay? This is a far more precise measurement because this is not exactly 90 degrees. I was using a rough guesstimate there.
Does 6 have a unit?
It would be whatever units the radius was being measured in. That's a really good question, David. If the 4 was in inches, then the 6 would be inches. If the 4 was in miles, then the 6 would be miles. So I'm not dealing with units yet, but yes, it absolutely will have a unit. Did I answer your question?
Yeah.
Okay. What if I'm looking for theta? Which is going to be the easiest formula to use? The one on the left, the one in the middle, or the one on the right? One on the left will be easiest. Again, keep in mind I can always use that original one and then just divide out whatever I don't want. But I'm going to use the one on the left. So I will say that theta is equal to S, which is 3, over R, which is 1, and theta, or the number of radians in the circle whose radius is 1 that subtends, cuts off an arc of 3, would be how many radians? 3. Pretty basic. Let's see. Let's go to 19 because it's the second 19. Because it's a little bit more difficult. It's word problem-esque. And word problems tend to throw you guys into oblivion. The issue with this one is they were not quite so clear on which is the arc, which is the radius, and which is the radians. So see if you can figure out what it is they're asking you to find and what the other two measures are. So I'm just going to put off to the side here. I'm trying to figure out what S is, what R is, and what radians there are. And I'm going to be looking for one of those. And the other two are in there somewhere. Can you figure out which is which? The next thing that I have to do is I've got to learn how to switch back and forth and back. So if they give me degrees and I really wanted radians, or they give me radians and I really wanted degrees, I can use the methods on this page to transfer back and forth. I need you to remember that 180 and pi are exactly the same thing. So that if I have degrees and I want to transfer to radians, I want to basically multiply by some form of 1 so that the degrees will divide out and the radians, which have pi, will go in. So my formula for changing from degrees to radians will be to multiply by pi over 180. And that means that 180 degrees, when I multiply